Hey guys, this is Mr. Ford. I'm going to be teaching over the 7.7 inverse of the trigonometric functions today. So our goal is that we will understand how to use inverse of trigonometric functions to find a missing angle. So yesterday what we did is we had one angle and one side, right? And I said there's three different ways we can figure out that other side. I can use sine, I can use cosine, and I can use tangent. So we use the given angle and the given side to find the missing side. So here's what's different today. Today we have two of the sides of a triangle that are given. We must find the missing angle. So here's a little secret. Each trigonometric function, sine, cosine, and tangent, they have these things called inverse trigonometric functions. These are what we will use to find the missing angle given two sides. Okay? So this is supposed to go up here, actually. So yesterday, here's what we did. We said that the sine of an angle is equal to that other side, okay? But today's goal is we're trying to find what the angle is. So we're going to use this thing called the inverse. So here's how I write the inverse. So I say sine -1, so that's the inverse, of whatever this normally is. So it's x, so it's x equals theta. Okay, x represents the ratio of the sides, right? So opposite over hypotenuse. So I have cosine of theta yesterday is equal to x. Today I have the inverse of cosine of x is equal to theta. Okay? And then yesterday I said the tangent of theta is equal to x. And today I'm going to tell you that the inverse of tangent of x is equal to theta. So this second one here is just me trying to figure out what the angle is. Boom, boom, boom. Okay? So let's let that marinate a little bit here. So let's figure out the missing sides of this. So I'll use Pythagorean Theorem. So we'll call that x. So I'm going to say that 4 squared plus x squared, that's equal to 5 squared. So I have 16 plus x squared is equal to 25. Right? So then I'll say that x squared is equal to 9. I subtracted 16 from both sides. Now I'll square root both sides. So x is equal to 3. Okay? I didn't mean to put this one on there, so we're just going to scratch it out because we already know that one. So I'll explain that here in a second. So I'm going to add a theta here. Okay? So at this point, I'm going to stand at this one. Okay? And I'm going to look directly across from me, and I'm going to say, that's my opposite side. Okay? I'm trying to find the inverse of sine here. So I'm trying to find this angle here, right? So I know if I'm trying to find this angle, I need my opposite side and my hypotenuse. Because remember that legend, SOHCAHTOA. I know that this one has an O and an H in it. Okay? So I know that's sine. So I say the sine of, and I guess I forgot to solve my Pythagorean theorem here. Oh, no, I didn't. 3. So I'll say that the sine of the opposite side over the hypotenuse, so the inverse of sine of 3 of 5. Another fancy way to write this is arc of sine, by the way, of 3 over 5. Okay, so I'll say the arc sine. So put that into your calculator. I'm doing it as well. So the arc sine of 3 over 5 is roughly 36.87 degrees. Okay? Now on to the next one. So I'm going to look at this angle this time. So I know that this one is 36.87 degrees. So now I'm trying to find this missing angle. Okay? So to find this one, I say, how do I find that? So let's use cosine on this one. So I'll say my adjacent side is here, and I'll say my hypotenuse is here. So I have A and H on this one. Okay? I'll say that, so 3 over 5, right? So I'll say the arc cosine of 3 over 5. Let's see what that's equal to. Type it into your calculator. so the inverse of cosine of 3 of 5, is just equal to 53.13 degrees. So that's how I found that angle there. Right? Now I could have said, well, like if I didn't have, so I was just using cosine here, but I could have used sine as well. So we're just going to look at the examples now. Okay? So I say solve for x. And these are the only sides I have listed. Okay? So basically, here, I'm going to try to solve for the angle, or x at least. So in this case, here's my person. I'm going to look out, and I see I have an opposite side, and I have an adjacent side. Okay? So this tells me it's going to be, and I'm trying to find the angle, this tells me it's going to be the inverse of the opposite side over the adjacent side. Okay, so let's see what that gives us. Okay, I got 35.39 degrees, which would make sense. Okay, on to the next one. So if my reference is down here, and I have my person, my opposite side is going to be 40, and then I have my hypotenuse. So in this case, it's going to be what? Sine? So I have SOHCAHTOA. SOHCAHTOA, okay? So my opposite side is 40, so I'll say the inverse of sine, that's 40 over 42. What is that equal to? Okay, so let's do it. So the inverse of sine, okay, of 40 divided by 42. That's going to be roughly 72.25 degrees. Okay, so 72.25 degrees. On to the next one. So this one, here's my x. Okay, so I look directly across. I have an opposite over a hypotenuse. That tells me it's going to be the inverse of sine. And I'll say that is 10 over 39. And that's equal to, oh, my calculator has an add. Okay, so I'll do 10 divided by 39. Okay, and that's roughly 14.86 degrees. Okay, now what about 4? Something should be like, oh, this is a little bit different, right? Because I do have my degrees. Now my x is on the outside. So this is actually going back to what we did yesterday. So I need to not be thrown off by that. So in this case, I have my person up here, right? So I know I have my adjacent side and my hypotenuse. So I have my adjacent, my hypotenuse. So I know that this is just cosine of 60 is equal to the adjacent side over the hypotenuse. So I know this is equal to 11 cosine of 60, which is equal to x. Okay, so let's go ahead and put that into our calculator. So 11 cosine of 60 cosine of 60. This is roughly 5.5. Or it's exactly 5.5. Or you could write 11 over 2. Okay. Moving on. So my x is again on the outside. I have my reference point here. So I say, oh, I have my adjacent side again, and I have my hypotenuse. Okay, so that tells me I'll use cosine. So say the cosine of 37 degrees is equal to my adjacent side over my hypotenuse. So in this case, I multiply both sides by x. So I'll get x cosine of 37 is equal to 11. Divide both sides by the cosine of 37. Cosine of 37. So I'll say x is equal to 11 divided by cosine of 37. We'll see what that's approximately equal to. So I'll say 11 divided by the cosine of 37. And I get roughly 13, so 13.8. 13.8. Okay, then for the last one. So I'm trying to find x. So I say I have my opposite side and my adjacent side. So this tells me I'm going to be using the inverse of tangent, SOHCAHTOA. Okay? So I'll say the inverse of tangent, I'll say the inverse tangent of 14 over 29. Let's do that. Arctan of 14 divided by 29. And that's going to be roughly 25.77 degrees. Okay, so that's all I have for you today. Just remember, if you're finding the angle, all you do is plug this into the inverse.